Hello there. Welcome to this video where you get to learn more on how you can approach various GMAT questions in the GMAT exam. And in these videos, we do select questions from various topics and we walk through them together with you to show you how you can approach the questions using various strategies as you learn better approaches and also probably gain a better understanding on how you can do so. My name is Joshua Obuya, trainer and a mentor the Kenya Edit program under the GMAT training section. Welcome aboard and hope you will learn more. In this session, I'd like to look at root problems in the GMAT exam. We will be looking at how root problems are presented or actually just tested and how can you tackle them. So that is what we'll be looking at in this session. And basically what I can say is that they don't really have much difference in terms of how you approach algebra. Knowledge of algebra really comes in handy in solving such problems, yet there are number properties kind of problems. So let's dive in straight away and take a look at them. So the first category of questions, we're going to look at sub 600 level questions. These are questions which don't really require much thought put to it to be able to solve them. By basically just being able to translate or just apply the basic principles or the concepts, you can be able to solve these questions. So for instance, we have a question asking us, what is the value of the integer n if all that the square root of 16 all over 10 raised to power n and all of it squared is equal to 0.04 squared. So pause the video, you can attempt the question, then you can come back and see how we address them. So, okay. So we have 16 over 10 raised to power n, all of it square root, and then it's squared is equal to 0.04 squared. So as it is, we can easily just, first of all, just see if you can simplify this to this basic form, the simplest form possible. Like if you square this, if you square both sides as actually the signs do indicate, it will get rid of the square root sign on the left-hand side, and then we'll have a different value for this on the right-hand side. Something else to note is that we have the numbers, the expressions in two number forms. One is a fraction, the other one is a decimal point. So it will be prudent to try and solve them actually have them in the same format as we solve them. So this will be, if we square this, the square root goes away, we'll have 16 or 10 raised to power n. This will be actually, if you square 0.04, you'll have 0.0016, you'll have 4 decimal places. So to make it be more or less similar, I think it's we'll go the fraction root. So we'll have 16 raised to power 10, 16 divided by 10, 16 over 10 raised to power n is equal to 16 over this is 10,000. So as you can see, if you divide both sides by 16, they will cancel and you'll end up having 1 out of 10 raised to power n is equal to 1 out of 10 raised to power 4. It's the same thing. So you have 10 raised to power n and 10 raised to power 4, and it's pretty much direct. You can see that n is equal to 4. N equals to 4. That is the correct answer in this question. It's pretty much straightforward, pretty much simple, not much to think about, not much thought to put through, and you have your answer. And let's go a notch higher and try and attempt questions which are of higher difficulty. For instance, now 600 to 650 level question. If you have a question like this, 1 over, what is also, the question asks you what this will be equal to, and you have multiple choices. 1 all over 4 minus root of 15, then you square all that. What do you have? So look at this question, first of all, what I would do is that we're seeing a whole expression. And when you have expressions such as this here's when now the algebra concept starts kicking in and algebraic identities can be applied. So for instance, we want to see how we can get rid of the square root sign, or we can simplify it and only have one value instead of actually having a numerator and denominator, because that is what the answer is. And one way of doing that is by when you look at the expressions, try and see how you can get rid of this. And what that can be done is by actually multiplying this by 1, this whole expression, the whole expression by 1. And that means, let's see, 1 divided by 4 minus root of 15. Then you have all of it squared. to multiply by 1, to actually multiply it by 1, you need to get an expression which will be the same. And you can probably just see that the identities you know we have a plus b squared, have a minus b squared, then we have a plus b, then a minus b as an ht. And this normally gives us a squared minus b squared. So we can use this actually because this seems to be able to get rid of the root sign in the denominator and probably now see what you have in the numerator. So what can we do? So we can actually multiply it by the counter value of it. So you'll have 1 all over 4 minus root 15 multiplied by 4 plus root 15 all over 4 plus root 15. So here now, this one actually is actually 1, and it will help get rid of the denominator because it'll have 4 minus root 15 multiplied by 4 plus root 15. So this will give us 16 minus 15 because it literally is a square on both sides. So you end up having 4 minus root 15 or plus root 15 in the numerator all over 16 minus 15, which is 1. Yeah. So that's what we have as the simplified version of this whole expression. So what do you do next? Now that you have it as 4 plus root 15 as the simplified version, then now I can go ahead and solve for the square of it. 4 plus root 15 squared. What is this? So this actually is a plus b squared. We'll have a squared plus b squared plus 2ab, or a plus 2ab plus b squared. That's what we'll have. So, and in this one now we can go ahead, let's just clear some space. Let's create some more space for us to work with. Now that you have a squared plus 2ab plus b squared, that means we'll have 16 plus 2 into 4 root 15, then plus 15. 4 plus, so what you'll have is 16 plus 2 into 4 times root 15 plus 15 itself. So what do we have? We'll end up having 16 plus 15 is 31 plus 2 times 15 times 4. So that will be 31 plus 8 root 15. And that is now simplified, and that is the answer choice C. That is the answer to this question. So it's a bit long, but yes, that is how to go about it. The moment you start doing them and do more practice, over time it gets shorter, and you can do them pretty much quickly. So the biggest thing is to figure out how do you approach this? How do you get rid of the denominator? That is the next thing.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
So let's go to another question, a 650 to 700 level question. And as you can see now, as you get higher into the difficulty levels, we start now applying other techniques or more logic and reasoning to be able to get the answers. That is what normally happens with higher difficulty questions. We get to reason further and apply multiple concepts in actually approaching a question. So here we have a question actually asking us for 9 plus root 80 all of its square root plus 9 minus root 80 all of its square root, then square that one. What do we get if we do that? So that will be, that's now what we'll like to address next. So these are naturally, as you see, this is more or less the same identities that we do have. A plus b squared. That's what we'll have. That is for which a is 9 plus root 80 square root, and b is 9 minus root 80 square root. So that is what we'll have. We need to address first. So a plus b squared will give us a squared plus b squared plus 2ab. That's to how. So this means that you'll have a squared will be 9 minus root 8, 9 plus root 80. Then all of it square root squared plus b squared 9 minus root 80. Then all of it's a square root of all that, then a square it as well. Then plus 2 into 9 minus root 80 square root times 9 plus root 80 square root, all of it. So you multiply both sides. So that's a bigger bracket all around it. So that's what you'll end up having. So if you remove the brackets, you'll have 9 plus root 80, because, okay, not the bracket, but if you square it, the square root will go plus 9 minus root 80, then plus, this will be 2 into 9 squared, because you have a plus b, a minus b, which ends up being a squared plus b, a squared minus b squared. So you'll have 81, which is 9 squared minus 80. That's what we'll end up having. So in this simplified, we have 80, the root 80 is cancelling. 9 plus 9 will have 18. Then 80 minus 81 minus 80 will have 1, so we'll have 2. So the answer will end up being 20. Answer choice E. So it looks a bit cumbersome, but it's been pretty much, if you actually have the identities in place and can actually find a way that you can simplify this, then you can get your answer. So this is how you approach such a question as well. Now let's look at one more question before now I can call it a day. If the sum of the square roots of two integers is root 9 plus 6 root 2, what is the sum of the squares of these two integers? So this is a word problem. Let's now have it probably just mathematical way. So we have the sum of square roots of two integers, let's call them a and b, root a plus root b. The sum of the square roots is equal to 9 plus 6 root 2, all of it square root. Then the question asks us to find out what is the sum of the squares of these two numbers. So that is a squared plus b squared. That's what we need to find out. So a squared plus b squared. So let's see. How can we simplify this expression, first of all, to be able to get the values of a and b, and probably see how we can be able to get a plus b squared. That's what we're being asked. In whichever way you actually have this, as long as you can have a plus b squared singled out, then you have an answer. So we can square both sides. If you square both sides, we'll have a plus b squared. Because we're squaring the whole left-hand side and the right-hand side for it to be able to approach it algebraically. So if you square both sides, let's say this one squared, then also that one squared, what do we have? We'll have root a squared, we'll have a, plus root b squared is b, plus 2ab. 2 root a root b is actually 2 root ab multiplied together. Then this one will be equal to 9 plus 6 root 2, because the square root sign will also go. So we'll have 9 plus 6 root 2. That's what we have. So from this expression, we can see that we have a root on one side and we also have a root on one side. Then we have a whole number. Since we've been told that there are two integers, we can logically deduce that a plus b is equal to 9. So we can write this somewhere. A plus b is equal to 9. And then 2 root ab is equal to 6 root 2. 2 root ab is equal to 6 root 2. So root ab most likely is equal to 3 root 2. Can we find what ab is? If you square both sides, you'll have ab 3 root 2, 3 times root 2, 3 squared. If you square both sides, you'll have 9 times 2, which is 18. That will be ab in itself. So we have ab is equal to 18. at this point, in an exam setting, if someone is short of time, then actually we can reduce that. We can say that possibly if there are integers, we can find sets of numbers that only how that can able to meet these two conditions, such that a plus b is actually 9 and a times b is actually 18. So we can actually solve for these and find the sets of numbers by getting the factors of both. Actually, the factors of 18, which if you add them, you get 9. So that would be the shortest way to go about it. So factors of 18 will have 1, 2, 3, 6, then 9, and 18 itself. So of course, you don't need this other part. You only end it up at this place. So you only have 6 and 3 as factors of 18, which if you add them, you can get 9. So at this point, you can see that a plus b is 9, a times b is 18. So if you asked for a squared plus b squared, you can have 3 squared plus 6 squared, which is 9 plus 36, which is 45, which is answer choice C. That is the shortest way of being able to approach it. How about the longer way that also can be used to approach this? The longer way is now, given this information, a plus b squared, we can also go ahead and also find a way of having a plus b squared exist. Since you have this knowledge and you have a plus b is equal to 9 and you have ab equals to 18. What if we were to find the squares of a plus b squared? A plus b is equal to 9, then you square it. This one will have, if you actually square this, you'll have a squared plus b squared plus 2ab, which is equal to 81. So you have a plus b squared in this case, and you also have 2ab. 2ab, since ab is 18 already, 2ab will be 36. So a squared plus b squared is equal to 36. No, plus 36 is equal to 81. So a squared plus b squared. Check 36 the left-hand side and subtract to get 45, which is still the same answer you got. So you have two ways of approaching this, and the easier one, the shorter one, which saves on time as well, is the other one. And this one also is pretty much accurate and can help you solve, but you don't need to go through this. You can choose which one to go with, which one to leave out. So that is how you can approach these root problem questions that tend to present themselves. And till next time, thank you and see you again. Bye.